In the cold vacuum of space drifts a small, silent traveler. Its mission was to explore the outer planets, but now it is exploring the universe. It left the world that built it, and it will outlive even the stars themselves. Long after the sun has faded, and Earth is only a memory written in the dust of time. Across time deeper than history, and distances greater than imagination, it will carry a fragment of who we were into a future we will never see. Chapter 1 Launch 1977. Voyager 1 embarks on an odyssey that will forever alter our understanding of the cosmos. It lifts off atop a Titan IIIe rocket, merely a fortnight behind its twin, Voyager 2. This grand endeavor was born from a fleeting cosmic alignment. The gas giants were positioned perfectly, allowing a probe to slingshot past multiple worlds using gravitational pulls, a method potent enough to transform a brief flyby into an epic trek across the solar system. Voyager 1 is equipped with an array of sensors: imagers, spectrometers, magnetometers, plasma tools, and monitors built to gauge the intense radiation permeating the void between planets. Affixed to the probe's exterior, though, is an artifact arguably more profound than its scientific gear: a copper phonograph record coated in gold, the Voyager Golden Record. It holds photographs, natural sounds, salutations in dozens of languages, melodies, and notes meant for any being or entity that might eventually find it. It additionally features a playback guide and a pulsar map, a method to pinpoint Earth using rapidly spinning stars. Since the moment of liftoff, no return ticket was ever issued. Voyager 1 was engineered to endure the void, the freezing dark, and the radiation just long enough to complete her primary goals, and then to drift onward, for as long as the laws of physics permit. Chapter 2 Jupiter 1979. Voyager 1 arrives at Jupiter, a turbulent realm of storms and lightning. Her lenses document atmospheric violence on a colossal scale: jet streams roaring at 1,500 kilometers per hour, cyclones erupting and dissipating, ammonia clouds weaving intricate designs, and the Great Red Spot, an anticyclone spanning 16,000 kilometers that could effortlessly engulf our home world. Yet the most shocking discovery does not lie on the gas giant itself. While flying past Io, a volcanic moon of Jupiter, researchers observed something astonishing: geologic fury, live volcanic plumes on an alien world. Certain eruptions shoot 100 kilometers into the void, clearly visible against the blackness of space. The probe also surveys Europa, Ganymede, and Callisto, the other massive Galilean moons. Through the cameras, Europa looks remarkably pristine and icy, fractured by reddish fissures, clues of a frozen shell warped by tidal friction. Ganymede reveals its own grooved landscapes, while Callisto looks primordial, scarred by countless impacts. Then comes the unseen domain of Jupiter, its immense magnetic field. This magnetic bubble is gargantuan. It captures atomic particles, generating radiation zones vastly more lethal than Earth's Van Allen belts. The spacecraft's sensors sample this deadly plasma firsthand, charting a hostile void capable of frying circuitry. Following this flyby, Jupiter gifts Voyager the exact momentum she requires: a gravitational slingshot. She arcs around the giant, siphoning a tiny portion of its orbital momentum, and transforms it into velocity and an altered path toward the outer dark. Chapter 3 Saturn 1980. Saturn emerges as a golden sphere bound by majestic rings. Viewed from our world, these rings seem like a solid, luminous halo. At close range, Voyager 1 exposes extreme detail: thousands of distinct bands, empty divisions, spiral density waves, and sharp borders, all sculpted by orbital resonance and shepherd moons. This disk is vast. It consists primarily of frozen water fragments varying from microscopic grains to house-sized chunks, stretching outward for hundreds of thousands of kilometers. The probe investigates Saturn's magnetic environment too, alongside the satellites trapped inside it. Certain satellites function as cosmic architects, defining ring boundaries and clearing out lanes. Others exhibit crusts molded by ancient collisions and subsurface heating. Yet the ultimate prize is Titan, Titan is bigger than the planet Mercury and shrouded in a dense, opaque sky. It stands as the sole satellite in our system possessing an envelope thick enough to entirely obscure its ground. This sky is primarily nitrogen, laced with methane and organic smog, pressing down with a force 50% greater than Earth's sea level. Ultraviolet Titan is crucial because such a heavy atmosphere acts as a giant chemical reactor. Light and charged ions shatter basic molecules, fusing them back together into complex organic chains. Within the frigid outer system, these new elements can create orange smog, liquid methane storms, and dune fields. Voyager sweeps past Titan at a tight distance, curving her flight path and launching her on an escape velocity out of the Sun's domain. Chapter 4, The Family Portrait, 1990. By 1990, Voyager pivots her lenses back toward the inner planets for one last look. From a distance of almost 6 billion kilometers, she snaps a family portrait, a stitched panorama of our cosmic neighborhood. Within a single scattered beam of light, our world shows up as a minuscule speck, the pale blue dot. All of human history, every ambition, every memory, reduced to less than a single pixel. Following this final photograph, her imaging systems are permanently disabled to save electricity. From this moment forward, she races toward the edge of the heliosphere at a blistering 17 kilometers per second. Chapter 5, The Heliopause, 2012. A final frontier awaits, the heliopause. This is the exact threshold where the outward push of the solar wind meets the inward crush of the interstellar medium. Breaching this border is not a visible event. Voyager witnesses no physical shift. She only registers the data. Nearing the boundary, the surrounding plasma drastically transforms. Sensors log a sudden plunge in solar-borne particles, accompanied by a massive spike in galactic cosmic rays bleeding in from deep space. Then, on August 25, 2012, Voyager pierces the heliopause and officially enters interstellar space, the true void between the stars. Chapter 6, The Present, 2026. Approaching late 2026, Voyager hits a range of 25.9 billion kilometers, standing as the first artificial construct to sit one light day away from home. A radio signal now requires an entire day to make the one-way trip between our planet and the probe. An instruction transmitted today won't reach her until tomorrow. Her confirmation won't return until the following day. Concurrently, the spacecraft's electrical heartbeat is fading. The plutonium-fueled thermoelectric generators keeping her alive are steadily decaying. Across the decades, this energy loss compels mission control to power off her instruments sequentially, just to keep her core systems breathing. Chapter 7, The Last Measurements, 2037. Voyager will have been drifting for 60 years. Her voltage has dwindled to a mere shadow of its launch capacity, and nearly all sensors have gone dark. NASA projects she might maintain a fragile link with the Deep Space Network up until this era. Yet, well before the ultimate silence, her scientific value will shrink to the final readings of her last surviving tool. To us on Earth, she won't seem to perish. She will merely cease to reply. From this moment on, Voyager transitions into what she was always destined to become: a solitary wanderer in the abyss, gliding forward, oblivious to whether anyone is still tracking her signal. Chapter 8, Gliese 445 to 40,272. Roughly 40 millennia from now, Voyager will sail relatively close to an alien sun. Gliese 445. Her nearest pass will still remain approximately 1.7 light-years away from its glow. The gravitational slingshots at Jupiter and Saturn forever altered her course through the planetary realm. Out here beyond the heliosphere, there are no more planetary boosts to be found. In the interstellar void, the gaps are so unfathomably vast that even our fastest machines appear practically stationary. By this epoch, Voyager's transmitter is dead. No one is plotting her coordinates with daily telemetry. No one is left who remembers the minds that designed her. She is a drifting monument to a species that may have long since vanished. Chapter 9, Andromeda collision 3 billion. Fast forward 3 to 4 billion years, and the sheer scale of this narrative shifts entirely. Voyager 1 is no longer gravitationally tethered to the Sun's domain. She is lost somewhere within the Milky Way, a wanderer whose precise coordinates would be impossible to calculate. Yet the galaxy enveloping her is far from still. The Andromeda galaxy, our closest massive neighbor, has been falling toward us for eons. As the eons pass, the void between them shrinks, until Andromeda entirely consumes the night. When the collision ignites, Andromeda and the Milky Way will phase through one another, their gravity warping the stars, ultimately fusing into a single, massive elliptical galaxy. If Voyager had eyes, it would witness a cosmic ballet of starlight and dust, a spectacle unfolding over billions of years. Chapter 10: The Fate of Stars 10 trillion. The present age of the cosmos sits at roughly 13.8 billion years. 10 trillion years stretches approximately 1,000 times further into the future. By this epoch, the stelliferous era of brilliant, burning suns has long since concluded. Only the dimmest, smallest red dwarfs possess the fuel to keep glowing across such immense stretches of time. They consume their hydrogen at a glacial pace, surviving for trillions of years. Yet, even their fires must eventually burn out. As free hydrogen is exhausted and new stars cease to ignite, galaxies devolve into graveyards of dead stellar cores. The cosmic canvas goes dark. The universe grows profoundly silent. Should Voyager's hull remain intact, she is now vastly older than almost every star that ever illuminated our galaxy. Chapter 11: Eternity 10 Decillion. Past the death of the final stars, time itself enters the realm of pure theory. One ultimate fate is the decay of the proton. Solid matter would slowly disintegrate as the very building blocks of atoms dissolve. Every physical structure left would evaporate into a mist of subatomic radiation. If Voyager endures to this unimaginable era, the fabric of reality itself will begin to unmake her. She voyaged further into the dark than her creators ever dared to dream, yet her golden record survives as proof that in the infinite expanse of the void, humanity looked up and reached out.